Hi, I'm Rick Palani and welcome to our virtual trade show for PMMI. Sorry we don't see you live in Chicago, but here you are on tape here in Dayton, Ohio. This is our lab and we're going to talk to you today about how to dot your way to a greener day using our Tesla all-electric 24-volt actuated gun. The Tesla is kind of revolutionary to the packaging industry. If you want to think about it, most of your guns you're used to are pneumatic, and a pneumatic gun requires air and therefore it has seals. And you'll see that guns a lot of times will, out of their weep holes, will be adhesive leaking out of it due to the seals failures. Most pneumatic guns will have maybe 5,000 to 50,000 cycles before they need some type of spare part or repair. The Tesla is unique in the aspect that it's all electric, so there are no dynamic seals to fail. So on the Tesla, you're looking at a 20% longer service life than a pneumatic valve. And what's nice about it is it runs off the same 24-volt signal that your pneumatic applicator runs off of. So there's really no change for what you have to do in order to go from pneumatic to electric. This also means that you're not using compressed air any longer. Compressed air is a very expensive resource, and it's something that you have to bring to the machine, you have to bring to the gun, and a pneumatic gun will operate differently depending on what type of pneumatic pressure is coming to it. If the pneumatic area pressure drops, then the gun doesn't cycle, or it wants to string, or it wants to drool. You'll never have that problem with a Tesla gun. You'll always operate the same way each and every time. The Tesla is also very, very robust. This, I wish you could feel this, but it weighs about twice of that of a pneumatic applicator. It's a tank. It will last a very long time. So you're looking at about 1 billion cycles for this gun versus 50 million for a pneumatic applicator. Now, we talked about how to dot your way to a greener day. So what does that mean? What we're gonna do is, on a packaging application, what we're going to do is take what you normally would do as a bead, which would be a solid line of adhesive, and what we're going to do is we're going to dot it. We're going to take that 24-volt signal and we're going to run it through a dot box and we're going to break it into these dots. When you have a very long bead, there's a lot of residual heat that sits in the product. So that can lead to pop opens a lot of times. So it's kind of like you have to think about it as a jelly sandwich. If you've got a carton and both sides are glued together and it pops open and you've got glue on both sides, then you've got a cohesive failure. A lot of times that's because there's too much adhesive on the carton, and that's why you get the pop open. Going to dotting really kind of eliminates that, because now you have very individual applications of glue with the same amount of heat through that. So I'm using 50% glue and you can still see how I'm getting great fiber tear. If you try to stitch a bead, you're still basically having just larger beads with a small break in between. So you're really not gaining that much for your application. But in this case, when we do the dotting, we're reducing glue by 50% and we're still getting a good tear pattern. Now, you may not know about Bomber HHS, but we've been in the business for a long time. We're really known for making the carton, for making the folding carton. The application that we do is for very high speed cold adhesive gluing. Cartons like this will run anywhere between 1,000 and 1,500 feet a minute. That's incredibly fast, much faster than what you normally run in general packaging. So what this does is it says that we know how to run an electric gun. We know how to make an electric gun last long. We know how to dispense the adhesive. And we've taken that knowledge and we've transferred it to hot melt technology. And that's what we've done with Tesla. In order to get the Tesla to work the way you want it to, we've developed a dot board. And what the dot board does is it takes that 24-volt signal. We're able to program it, and this can go either into the OEM box and run from the PLC and take that 24-volt signal, or we have a dot box that we can sell, and that goes in between the applications. So you can either do it inside, DIN rail mounted, or we can do it as a separate box in the system itself. But by taking this dot board, we're able to do that signal, and then we can break it into a 50%, 60%, 30%, whatever works for your application. And we can add the Tesla and the dot box to your existing application. Don't even have to change your hoses or your melter. We can just add the Tesla gun, add the dot board, and you can start dotting. Now in this application, we're showing all HHS. So what we have is we have our X-melt unit, which warms up in about 20 to 25 minutes. That's typically twice as fast as most melters in the market right now. So you're using a lot less heat, and the way this is set up, if you want to come in and take a quick look, we've got it set up so it's got the fins, so the top portion is unheated and only the bottom portion is heated. We run that through this hose, and this hose is only 30 millimeters in diameter. Most hoses are 45 millimeters in diameter. It's like trying to wrestle an anaconda through your OEM machine. So by being able to go to the smaller diameter hoses, you're not losing anything because the hose core is the same as what it would be on the larger hose for the 45 millimeter. So it's an 8 millimeter hose core, which will give you the same flow. So you're able to get the flow and have a smaller overall profile, which is very beneficial for any type of maintenance, or if you're trying to take longer hoses through the machines. And then it comes to our Tesla gun. This whole system right now is set at 350 degrees. The Tesla with the cover on it, what this cover does is it protects you. So for incidental contact, when you're trying to change a nozzle or take this off, it's going to protect you for coming in contact with it. And that's a really beneficial safety aspect for the machine. Now what I'm going to do here is I'm going to show you this. I'm going to show you something here with the Tesla gun. So what we're going to do is we're going to do a 50% glue savings. I'm going to run the gun. I'm going to run the speed of this very slow. And you can see here. The Tesla is very quiet. It's almost 30 decibels quieter than a pneumatic valve. And from what you can see here, this is 50% glue savings at that speed. And you can see that it's almost still a solid line, but there's 50% less glue at that same speed as what you would have in your application as if you were doing that full bead. Now what I'm going to do is run this again. And we're going to run it at a faster speed. Here we go. And you can see here, now we've got the individual dots. And now you can start to see the individual dots as the speed increases. In some cases, you can think of dotting as a poor man's run-up. So as the speed decreases on your line, let's say that you have a collapse or something stops, you're not going to have that squeeze out that you get or that dripping, because of the dotting is going to be able to maintain that same amount of volume for each dot that comes out. They're either just going to be spaced closer together or farther apart depending on the speed. So we're going to go ahead and take this back one more time. And we're going to increase the speed. And you can see the dots spread out, but you can see that the dots have remained in the same size as we go through the whole aspect of this demonstration. So let's take it back for the final one. And move it forward a little bit, there we go. And then we're going to do the final one at high speed. And so you can see that the dots are the same no matter what the speed is on this. So you're able to have the same amount of volume every single time, no matter what your speed is. So this is a really great way to control your volume, to control the amount of adhesive that you use, and be able to still get a really good bond on your application. Now, if you'd like to know more about this, at the end of this demonstration, there'll be a chat on the website, and we'd be more than happy to answer any questions that you may have about this. But Tesla is the next generation of what you want to go to in your hot melt equipment. It's going to save you glue, it's going to save you air, and it's going to save you spare parts. It's going to save you headaches. It's going to make your gluing aspects so much easier than what you've been currently doing. Thanks for your time today, and thank you for visiting us here at PMMI.